Okay, we're back on our head here. Got to figure out how much I'm going to cut this stud down. I already know I got to cut 40 or 56 thousandths off of the overall length. I got to see what the studs are sticking up over here out of the rocker box. Rocker arm out. Okay, so I just turned these down all the way in. So now the nut's flush here on the top. It's pretty close to it. So that one's basically 800 thousandths on that side. Let's see what this one is. So this is a depth gauge right here. You go from here to here. You get a measurement. This one's 822. So I always measure this stuff more than once. 821, and one more on the other side over here if we can get into it. I went too low on that. It's hard to get on this side. I'll turn it around the other way. $840. Oh, you know what I got? $826. Okay, so basically it's about $820 on this side, and this side over here was $813 to $800. Now I'm getting $830 because I'm holding it more straight. $830. Start on this side. Make sure on the low part. $818, $820. So it looks like about $820 is the stick-up height. So when I put the stud in here, I got to make sure I'm at least $820 or lower. Otherwise, it'll be higher than these two. All right, so we got our numbers. Because I got to make a stud out of this bolt. So if we're going to shave off the 56 off this end initially. Then I got to go in here 800 thousandths plus and make sure that bugs. This part is probably at least 830 to probably about 850 down straight up. That's where I'll turn it to my smaller size. So we're going to lose a couple threads in a transition between the two. We'll try to keep it to a minimum. But we are going to have to cut it down a little bit. Alright, so let's go over here to lathe. Do some playing. Do some more cutting. Where's my mic at? Great. Mike is missing. Where'd Mike go? Where Scooby's at, but where's Mike at? Not there, not there. Huh. There's Scooby. Scooby just got kicked in the head because he moved his head as my foot went by it. Okay, there's a couple mics, but these are not the ones that are supposed to be over there. This is one I'm going to use. You going to put your head where my foot goes again? You like being kicked in the head, Scooby? Should I take my foot like this, and he jumped up just as I went across his head. There's the mic. See what happens when people use your tools? They hide them from you. Okay, I'm going to put that mic back over there where it belongs. So that mic belongs over there. This mic here is the machining mark. Alright, see? They did a terrible job of hiding. I found it. Okay, so now we got our tools back. We can use them again. Okay, so we know we need 800 plus out here straight. Plus a transitional area. And we're going to cut off some. So that means we need over an inch sticking out of this thing. So I can't have the chuck any further than right here. So I'll put my thumbnail on the next thread in. Stick it in here. Measure it. That's 1 inch. We're going to come out a little bit more. There's an inch 050. Now, you're not supposed to chuck on threads. I just chucked on threads. Pretty good quality bolt. It's actually not wobbling too bad. These things tend to wobble a lot. It's not wobbling hardly at all. It's pretty good. It's a good quality bolt. Got that from boltdepot.com. There you go. You sell good parts. I'll tell you where I get stuff from. Okay, what I do not do is measure the overall height of this, which I cannot do because it's on the truck now. So we're just going to have to assume it's the right height. So I'm going to cut off too much number first. Take our indicator, put it down here so I can see the number. Touch off right there. So you move the indicator here in. Turn that off, you can hear me. So we touch right here, and you see how it starts pushing out of that. So you got to make sure you go at least 56 thousandths in this way, otherwise when you keep cutting you will lose where you're at. I always go at least 100 thou more than I want. So for now we're going to put it at 0. And we'll move it back and forth like this. See? It's done like this. Now that's cutting at the top of the markings, not the top of the bolt. So put that on. Go in until they touch. So it's going to be near 0, probably 5 above. Hear it right there cutting. It's only 1 above. It's pretty good for me. So now we got a good setting. We're going to go to 56 thousandths way over here is the height we need it to be cut to. So got this one, we'll move this side in and out. So we're at 0. This one moves it into the cutter that way. So there's 10, 15 thou. We're going to crank this down in here and move it in. That's your view. This is my view over here. You can put it where you had to get different views. Okay, it appears I'm way above my height. So I moved this up to cut that valve guide, and evidently it's way too high because it quit cutting because I'm too high. So I'm going to move this out. So that the cutter needs to be at the center height of the dimple in there, which is, I'm assuming that's why it quit cutting, but I can't see from that angle. Yeah, we're definitely high. So we loosen it up, drop it down a little bit, re-put it in, check it. It's a little low now. One skosh, crank it in, we're good. Okay, we're going to go until we touch. We know that was at 85. So we're going to reset our dial for 85 so we don't lose our dimension that we had. Go until we touch. We're at 85. Get the rest of our dimple off. Now, if you're a little bit low, you'll have a small little dimple. If you're a little high, you won't have anything. So we have a little titty right there, which you can barely see, but it's just a tick high. I mean, we're a little bit lower, but that titty's probably only about 5 thou thick, so we're probably only about 5 thou off on our height. It's close enough for me, I don't care. I'll kiss it with a file at the end. If I want to, I can cock it back up a little bit. This is kind of a hard material, tough. It's better to be a little bit low, which is a little bit of a negative. It makes it cut better, so I'm going to leave it slightly low. Stuff you learn when you're a machinist. Got a 15 thou coming off. Can't see very much of. Okay, well, that time I cut it all the way off. There's almost no dimple this time. Because now I had a load when I went across that surface, so there's almost no dimple at all now. Or no titty, not dimple, titty. Okay, we're going to put the camera over here and see if that works better for viewing. As long as the camera doesn't vibrate off the leg, we're okay. I haven't lost it yet. Here's another 15. I don't want to cut too much here because we are only holding on threads. They will loosen up. And then you destroy it. Okay, next number is our 46 right there. Okay, there's 46. So that should be exactly the same height as those other hardware ones. Now I'm going to go ahead and cut the hex off, which is going to be hard on our threads. It needs to come off. Cuts light and won't be too hard on the threads. It takes a little longer to do that, but it's better than destroying your bolt. We're going to do everything again. So there's our hex head just about done. See, the hex is now gone. I put it back in neutral. See, now there's no hex, so now we don't have that pulsing going on. I'm going to go ahead and check the torque on that to make sure it hasn't moved any. Yep, plenty of torque. Cut this whole hex head off, and then we start cutting the shank of the bolt down to a 5/16 diameter. And I gotta throw it in there. About a 20 cut. There's 30 pounds right here. Big cut. I think the tip of my carbide got chipped off that big chunk I heard earlier. Okay, now we're back at uneven cuts, so you go slow. We're cutting the thread off. Broke a chunk of the carbide off, I think. Oh yeah, definitely. You can tell by where the cutter is cutting out. So the cutter has a radius on it, so it's like looking at this. Instead of cutting on the leading edge, we're cutting way back here because the tip is bit broken off. So if you look at it really close, you can actually see it's not cutting where you want it to be. That one of those chunk noises I heard where it knocks the tip off. So this is 820 thousandths straight shank size, and then you have to taper it up into the 7/16 diameter after that. Now, I didn't set the dials for 800 thousandths, so I'm just going to go in here a little ways and guesstimate about where we're at. Take our scale right here and measure it. So I'm at about 840, 850 right now. Okay, so it's plenty. So I can either sharpen this bit, change it out, or just keep hogging away. Normally I just keep cutting away, don't care, but I'm trying to save the threads on this thing, so I don't want to destroy it. We're done with that. So I'm going to pull this out and change it. Blow some of the chips out of the hole. Try to get them out anyway. Okay, so this thing can have a big chunk out of it. Yeah, that's not a very good cutting edge anymore. I don't know if you can see it, but that whole edge is defunct. Ain't there no more. So here's a radius one that I sharpened, and this is one that's been sharpened even more because it's bigger. So we use a big ass one. I used to have a sharp edge where the corner's gone now. I'm cheap, so I resharpen my bits as much as I can. Which means I cut them way past where you should ever cut them. But that's because I'm cheap. Okay, now we got a new bit in there. Our height might be off. That looks good. Okay, so now I'm going to cut some more. Should cut better now. There's 30 thousandths. Big cut on this machine. So now we look to see what we're going to cut this time. So we got pulling a chip. Before I wasn't really doing it, I was rubbing it off. It's hard to do this one hand right here. I got to reset my hand. Here's the last of the thread we're cutting off. That's where we stopped before, was right there. Okay. So I'm going to measure this and see where we're at, because we don't want to overcut it. So I'm assuming we're probably, it looks pretty close to 3/8 of an inch. Okay, let's see what we got here in our mic. So we're at 7 and we're at 50. So we're 357. Okay, we got to go down to 5/16, which is 312.5. And bolts usually cut a little under, about 5 to 10 less than that. So I'm going to go about 305 or so. So 5/16 is 312 right there. So if you give 6 thou undersize, it'll be 305. So we're at 50 right now, so we got about 45, 50 thou to blow off of this. So these are double, so you go 1, it's actually 2 thousandths. Some lathes are 1 to 1, this is a 2 to 1 model. When the hand gets here, it's hard to control, so you go back up here to get better feed rate. Usually I use 2 hands. Or I could turn the power feed on if I want. Usually on short lengths I just do it by hand. Okay, that's about a little over 800 right there. Okay. So now we're getting close where we want. So that was 30, we had about 50 to go. So if I go another 10 right there, we'll be fine. Before I do that, I'm going to measure it just to make sure I didn't screw up my measurement. And we are really close. See, if I cut another 10, I cut too much. So you come back and measure. Okay, so we're going to put this about 12. Back up our free play. Loose machine because it's an old piece of crap. Okay, I'm going to use both hands this time. Get a lot better finish with a lighter cut. Right there. Measure it. I got 305. If you don't trust your eyeballs, use the caliper. Oh geez, it's 305. It's actually 304 when you're squeezing on the caliper. You take it off, it gains 1,000, so it's actually 304. I can live with that. Caliper's only accurate to 1 thou. Mics are accurate to tenths of thous. So the mic's always more accurate than a caliper. Always. And according to the mic, I am right on the money at 305 within a tenth. Caliper says I'm 1 thou off. That's why you don't trust calipers. Okay, so what's our depth? Our depth's about 825. So now what I'm going to do is I'm going to have to remember what number we're at, which is 12. I'm going to back up about 100 thou here, and I'm going to taper this on down and try to make it a nice blended dimension. And like I said, right now I'm about 830, so I got more than I need to be. But everything I cut off, I'm losing thread inside the tower. So right now our bolt is that long in there, so it does have a lot of thread. That's why I kept it really long, because I knew I was going to have to taper this. We're going to lose 150 thou here probably. The holding power. Okay, this is going to do by hand. Blending process. Okay, it's got a nice transitional taper into there with no undercut. So I don't know if you blow it up, you might be able to see it a little bit better, but it's now blended in there nicely. Okay, so now we got to put a little chamfer here on the nose of it, so the die will start easier. And then we try to screw it up real quickly. Roll it a little bit with this. Yeah. So now we're ready to get some threads on there. So there's how it looks like. That's your roughed out shank. Now it's ready to have threads. So I put a chamfer on it and then I rolled it over me a little ball edge. I like ball edges. And I'll come back after we thread it and probably do it again. And up here there's no real sharp edge up here because I cut it in there. So it's not too bad of a transition in there. Okay, so you got a couple ways of doing this. We can either cut the thread with a lathe, or we can use a die. 5/16 is fine. It's going to be one of these two. Not that one. This one is the 24. It says right on it too. Die holder. So use this crappy one, or I can use this one. I usually use this one. Okay, so if I'm quick and I'm in a hurry, I just put this thing in here. I usually put something behind here to push with, and I push the thing straight in, let it start cutting, and it'll usually wobble around like this a little bit because it's a crappy thread. So usually I don't do it that way, so usually I cut threads. So let me get set up for that. We'll be back.